Question number 3. A student investigated how the resistance of a piece of wire varies with its length. 3.1 is an A1 question and it is from the required practical activity number 15. The student must have the information about the practical about this topic. Figure number 2 is shown here. If you look into the figure number 2, it shows a circuit diagram. The ammeter is present. The piece of wire which needs to be tested is present here. Voltmeter is connected across the wire. The variable resistor is present which plays a very important role, and the battery or the cell is here. Explain why the student needed to adjust the variable resistor each time she changed the length of the wire. Variable resistor, it controls the resistance in the circuit. It increases or decreases the resistance in the circuit. The objective is to control the amount of the current flowing through the circuit. Otherwise, the temperature of the wire will increase or decrease, and it will affect the value of the resistance with the length. Let's see the model answer. The variable resistor controls the flow of the current in the circuit. The variable resistor controls the resistance of the circuit by increasing or decreasing the resistance. So it increases or decreases the resistance. As a result of that, the flow of current is controlled. The objective is to keep the constant current in the circuit or in the wire in such a way the temperature of the wire does not increase. 3.2 is an AO2 question and it is from the required practical activity number 15, and this question is from the current, resistance and potential difference topic. The length is given here, the potential difference is given here for the value 1, 2 and 3. The mean is taken, that is 0.17 volt, but the first reading is missing. Calculate the x in the table number 1. We need to find the value of x. We will use the formula for the mean. Mean is sum of all the values, our total number of values. We know that from the table the mean is 0.17 volt and sum of all the value is x plus 0.18 plus 0.15. Our total number of the values are 3. This 3 will go on the other side. This 0.33 will go on the other side and it will be subtracted. 0.51 minus 0.33. The answer is x is equal to 0.18 volt. Figure number 3 shows the results of 5 different lengths of wire. The length of the wire is in meter, it is along x-axis, and the resistance in ohm is along y-axis. If you see the graph is passing through the origin. And this question is from the topic of the current, resistance and potential difference. Describe the relationship between the length of the wire and the resistance of the wire. We can see that as the length is increasing, the resistance is increasing. And we can see that it is a straight line and it is passing through the region. A straight line passing through the region, it shows that the length of the wire and the resistance of the wire are directly proportional to each other. Let's see the model answer. The graph is a straight line and it is passing through the origin. So the resistance is directly proportional to the length of the wire. Student need to give this answer to get full 2 marks. A glucometer uses the resistance of a blood sample to calculate the glucose concentration in a person's blood. A key information is given here. A blood sample is put into a small tube which is put into the glucometer. The blood then acts like a resistance wire. Figure number 4 shows a relation between the resistance of the blood sample and glucose concentration. If you look here in figure number 4, we can see that the resistance is along y-axis and the glucose concentration in grams per liter is along x-axis. We can see that if the glucose concentration is increasing, the resistance of the blood is decreasing there. We have potential difference. We need to find the current, but we don't have the resistance. We have the formula V is equal to I times R. We can find the value of I by rearranging the values of V and R, but in the question the value of R is missing. But some key information is given here. The concentration of the glucose in the blood is 0.98 grams per liter. We will go back to figure number 4 to find the value of resistance by using the glucose concentration. From figure number 4, the glucose concentration is 0.98. If we go straight up to the graph, then we go on the left side, the answer is 7.5 ohm is the resistance. So we will use this value in our answer. Use figure number 4 at 0.98 grams per liter. The resistance of the blood is 7.5 ohms. Potential difference is already given here in the question, 0.9 volts. We need to find the value of the current. We will use the formula V is equal to IR. First substitute the values. Potential difference 0.9 and 7.5 ohm that we got from the figure number 4. To make I as a subject, 7.5 is go on the other side and if you divide 0.9 and the value is 0.12 ampere. So value of current is 0.12 ampere. 3.5 is a NEO3 question. A new tube is used each time a blood sample is tested. Explain why valid results are only obtained if each tube is identical. The question is why the tube is same type of the tube or identical tube in our investigation. The reason is if the tube which is used for the test is not identical, then it can affect the volume of the blood or it can affect the value of the glucose concentration in the blood. Therefore, every time we need to use the identical test tube or identical tube for the testing. Let's see the model answer. Same shape or the volume of the test tube is used as a control variable. This is a key information. It means that taking the same volume of the blood is used each time. The second mark is coming for this point to show that the blood concentration is acting as a resistance. Because if the shape of the test tube is different and the volume of the test tube or the tube used for the testing is different, it will affect the resistance of the blood.